First off, I would like to start off by thanking everyone for taking the time to attend today's presentation. My name is Lance Zurich, and I am the product manager for the fischertechnik Education Division over here at Studica. And as you probably guessed by signing up, today I'm going to provide you with an overview of fischertechnik's line of pre-assembled industrial simulation and training models. Now, whether you're an educator at the high school level who's involved in CTE training, a college professor, or maybe an industrial trainer teaching programming skills required in manufacturing, perhaps you're a company looking for ways to demonstrate your software-based solutions, or maybe just someone who's looking for ways to make IoT-related concepts easier to understand to employees or customers. In any of these cases, I believe that this presentation is going to offer you some important options for you to consider. And we're going to start off by considering the skills gap. Now, if you've attended any of our fischertechnik education webinars, I give a few of them, you've probably heard me discuss the importance of STEM education. STEM, of course, is the acronym that stands for science, technology, engineering, and mathematics. And it should really go without saying that STEM education has been perhaps the most discussed topic in the educational field over the last decade. Now, as many of us are aware, the push for developing STEM skills in students is in large part to help to best prepare them to take their place in the modern workforce. Not so long ago, when our parents or grandparents were entering the workforce, employers in areas such as manufacturing might have been satisfied with hiring workers who could demonstrate good motor skills and a solid work ethic. But as manufacturing has become more and more dependent upon automated processes and robotic control, employers now desperately need individuals who have a background in areas such as mechatronics, industrial electricity, mechanical components, and programming PLCs. And as it ties in directly with the solutions that we're going to be looking at in detail in this presentation, let's consider that last skill area I just touched upon, that of being a PLC programmer. Now, first off, for anyone who may not be familiar, let me just real briefly explain what a PLC is. The term PLC is an acronym, the letters of which stand for Programmable Logic Controller. And essentially, a programmable logic controller, or again, PLC, is a very specialized computer that's used to control the types of machines and automated processes that will typically be found in an industrial setting. And these are going to be things such as an automated manufacturing plant. Now, as the world of manufacturing becomes increasingly dependent upon these automated control systems, of course, the need for workers skilled in the programming of such systems grows exponentially. Now, to get a clear idea of just how highly prized these kind of programming skills are, here are some salary figures for PLC programmers as quoted from job search website nuvu.com. Quote, the average PLC programmer's salary in the USA is $78,000 per year or $40 per hour. Entry-level positions start at $43,924 per year, while the most experienced workers make up to $132,600 per year. Now, as I prepared the original notes for this webinar, I took a look at the list of current job openings for PLC programmers on nuvu.com, and this was back in February of 2020 when I had started putting the notes together. Now, the listings at that time showed 15 positions being advertised for PLC programmers with salaries of over $75,000. And two of them even listed starting salaries of $195,000 per year. Now, because of this trend, savvy students are increasingly enrolling in PLC training programs at the college and university level. And at the same time as this workforce of tomorrow gets their training, more and more manufacturing companies who face an urgent need right now are enrolling their incumbent workers into private training schools offering programs like this. So how long does it take to learn PLC programming? Well, depending on a student's background and experience, very basic PLC programming skills can be learned in as little as 30 to 40 hours of training. But of course, to be truly proficient in all five of the most widely used PLC programming languages listed here, as well as really learning how to efficiently troubleshoot and address errors and equipment breakdowns, of course, more training would be required. Now, once again, while many students can learn PLC programming skills in a college lab setting, there are many other options available. Of course, high school CTE, career and technical education programs, adult continuing ed programs, vocational training, technical training in trade schools, and employer-sponsored incumbent worker training programs, as I touched on before. Now, that all being said, the question that still arises for the educator, and that's whether you're the educator in the university or the vocational school classroom, or wherever you might be, is how do you teach PLC programming in a way that makes it engaging and relevant to the student, whatever their background? How do you get away from the dryness of textbooks and video presentations and instead make it realistic and hands-on? But there are other areas of focus beyond programming that need these solutions for demonstrating, exploring, and understanding different aspects of automation and control systems. Now, it could be that you're a company involved in creating or marketing a new type of software-based solution that's looking for ways to make more tangible processes, which might otherwise be perceived as too abstract. Or perhaps you want to test out something in a more realistic fashion. Maybe you're a manufacturer looking for ways to better visualize the production process for workers and stakeholders as you prepare to build a new factory. Or perhaps you're with a company looking for an engaging way to demonstrate your services and solutions in a public setting, such as a trade show. Now, in any of these cases, and of course there's more, there's a need for finding a solution that is engaging and which can effectively mimic and simulate real-world automated systems. And that brings us to the line of fischertechnik industrial simulation and training models. These models have been designed with the intent of providing a compact, engaging, and hands-on method for teaching and demonstrating high-end automated systems. The line of models consists of a series of pre-assembled small-scale models which are designed to replicate, in both appearance and in function, various automated robotic machines and systems that are commonly found in industrial and commercial manufacturing. But before we look at each of these models, I just want to provide you with a little bit of background about exactly what fischertechnik is, what it's about, where it came from. Now, fischertechnik has been creating tools for teaching students of all ages how technology works for over 50 years, all based around their unique building system. Now, what makes this fischertechnik building system unique is that unlike other popular construction systems where the components are designed to simply stack, with the fischertechnik system, it's all created with an engineering mindset. The core building block in the system is designed to enable attachment from all 6 sides, and because of this, it allows for almost limitless design possibilities. Now, many of the parts are designed to slide together and lock in place using a tongue and groove assembly method, and the hundreds of different parts available will also help builders to address very specific design needs. The fischertechnik system was developed back in the 1960s by German inventor Arthur Fischer, who's noted for countless innovations used in both construction and the automotive industries. Now, Mr. Fischer, at the time of his death in 2016, held more patents in his name than Thomas Alva Edison had amassed during his own lifetime. Now, besides fischertechnik, Mr. Fischer was also the inventor of synchronized flash photography, and that was back in 1949. And he's also the creator of the expanding nylon wall plug, which we've all used, which of course is used in conjunction with a screw or a bolt to help anchor heavy objects to walls. His company, the Fischer Group, employs thousands of workers worldwide, producing many variations of fastening devices used in building construction. They also produce numerous components used in automobile assembly, as well as providing consulting services to companies who wish to employ state-of-the-art manufacturing processes. Now, once again, the focus of fischertechnik sets, and it's whether those sets that are intended for the retail market or for classroom use, has always been on helping to foster an understanding of technology. Now, many of the products offered by fischertechnik for the education sector are what we would call subject-specific sets, focusing on different STEM-related areas, and this would be things like mechanics, pneumatics, robotics, renewable energy, and so on. Now, in many of these sets, students are asked to build a progression of models using the unique fischertechnik building system, and then perform various experiments with the models, which allow them to explore and understand the various aspects of that subject. Now, there are also sets that are designed to enable schools to offer a complete standards-focused curriculum-based program, and this is where the focus is on project-based learning. Now, in these project-based learning programs, students dive deep into areas like engineering, and they learn all aspects of the design process, which requires them to work in groups and to create various devices and automated machines to meet the criteria being put forth in a series of real-world style scenarios, all based upon their own trial and error, experimentation, and research. Now, the line of fischertechnik simulation solutions, which again are the focus of today's presentation, are something much different. The line consists, again, not of kits, but of a series of pre-assembled small-scale models, which again replicate in appearance and function various automated robotic machines and systems. Models in the fischertechnik simulation line include things like conveyor belts, punching machines, three-axis pick-and-place robotic arms, color sorting lines, and even high bay warehouse storage systems. Now, besides these individual models which focus on specific automated processes, fischertechnik also offers an integrated factory simulation model. And in the factory simulation model, 4 individual workstations are put together, and the workstations are a vacuum gripper robot, a high bay storage warehouse, a multi-processing station with an oven simulation, and a sorting line with color detection. These are all put together to work as one self-contained material cycle. And of course, we're going to discuss that in a little bit. But before we begin to look at the models in the simulation line in more detail, let me briefly outline some of the advantages of using fischertechnik solutions. Now, I do apologize in advance as the first few points are things I've touched on before, but in each case, I do think it's worth repeating. First off, fischertechnik simulation solutions offer educators a hands-on tool for teaching, exploring, and understanding various aspects of automation and programming. And this can be for understanding how automated systems work, or for having a tangible physical system to observe and work with in the programming or PLC learning environment. The models are once again designed to realistically replicate in both appearance and function common automated systems such as conveyor belts, sorting machines, robotic arms, and much more. Because the models are compact and in most cases tabletop sized, they are not only ideal for use in the classroom or in office demonstrations, but also for demonstrating software or other technology-based solutions in a trade show environment. The next aspect is quality. Each fischertechnik simulation model is a hand-assembled, high-quality, German-made product. Each of these models is available in a 24-volt version, designed for use with industry-standard PLCs. So it doesn't matter whether you use Allen Bradley controllers, if you prefer Siemens controllers, or controllers from manufacturers such as Honeywell, Mitsubishi, General Electric, you name it. Whoever it is, you can control your 24-volt models with the PLC and the programming language of the 6 you see, or that you saw listed earlier. You can use that and you're ready to go. Again, please note with these 24-volt versions that no PLC is included, and all programming and programming guidance, so any of these programming languages you want to use, and as well as any power sources or other hardware, are the responsibility of the end user. Of course, this should not be an issue, as these models are designed specifically for industrial users or for those teaching or exploring industrial processes involving PLC programming. In addition, for non-industrial users and educators not versed in or familiar with PLC programming, there are several models which are currently available in 9-volt variations. Now, in the cases of these 9-volt variations, they will ship pre-wired to fischertechnik's own proprietary robotic controllers, which are called the Robotics TXT controller. In the case of this, each is pre-programmed using fischertechnik's own RoboPro graphic programming software. Now, in the case of these models, the only additional component required is going to be the addition of a 120-volt power adapter, and we'll, of course, discuss that as we talk about the different models as they come up. But otherwise, essentially, these 9-volt variations are going to be ready to use outside of the box. So if it's something where you're not really involved with PLC programming, but you still want to explore automation and control, that's where this might be something you would want to look at. Moving right along. If you are involved in demonstrating or exploring IoT, which of course is also known as the Internet of Things, besides the fact that many end users have adapted many of the models in the primary line of simulation and training solutions for IoT purposes, besides that, fischertechnik now also offers a special IoT-focused version of the factory simulation, which is designed specifically for exploring and understanding cloud control and what is sometimes referred to as Factory 4.0. In the case of these models, they are designed to be both controlled and monitored from a special web-based dashboard. And we're, of course, going to look at these in more detail a little bit later in the presentation. Finally, Fischer-Technic simulation models are cost-effective. Now, if you've had the opportunity to look at any of the other hardware-based industrial simulation options that are available in the marketplace, you've probably noticed that the entry point for many of these products can easily be $30,000, $40,000, or even much more. Fischer-Technic simulation solutions, on the other hand, are available at just a fraction of that price, as well as being compact, realistic, and high-quality learning and demonstration tools. So on that note, let's start to look at some of the models which are available. The first model we're going to look at is the vacuum gripper robot. Now, the model you're going to see in this video is a model of the vacuum gripper robot, which is essentially a 3-axis robotic model with a vacuum gripping device. The model is designed to precisely pick up and position workpieces in 3-dimensional space. The model itself includes 3 encoder motors, 3 push-button limit switches, a vacuum suction device, a compressor, which is the blue brick component that you'll see in the video at some point, and a solenoid valve. The model's dimensions are approximately 9 by 19 by 15 inches, and it has a weight of just about 7 pounds. The 24-volt version of this model, as well as all of the first 5 24-volt models that we're going to be looking at today, each have a relay board for motor polarity reversal and both a multi-pin connector, 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connections for all inputs and outputs. Again, the 24-volt version of this model, as with all of the 24-volt versions, will require the end user to provide the PLC and the program. I will also mention that for this and all of the models we're going to look at today, the specs are also detailed in the product listings found on the Studica website, as well as in our product brochure, which I will provide information on obtaining at the end of this presentation. And as I see someone just came in now, we're just looking at the first of the models right now, which is the vacuum gripper robot. It's just going to finish up, and we're going to move along to the second. So you really haven't missed a lot yet. And again, that's the first model of the vacuum gripper robot. Next up, we are going to look at the automated high bay warehouse. The model you're going to see here features a transfer station with a conveyor belt, along with a shelf stacking mechanism for storing and retrieving workpiece carrier trays, and 9 individual storage spots. Components on this model include 2 encoder motors, 2 mini motors, 4 push-button limit switches, 2 photo transistors, 2 LED light barriers, and a selection of different colored workpieces along with carrier trays for each. Now, I will mention that this particular model is a favorite among educators I've spoken with who are involved in teaching programming. And the reason they like that is because it gives you a lot to work with in regards to the movements of the picker mechanism, as well as the precision required to properly store and retrieve each of these workpieces from the tray, from the little shelves that they're on, each step, which of course requires its very specific coding. So they like that for that purpose. Getting back to the dimensions for this model are approximately 19 by 28.5 by 15 inches, and it has a weight of about 18 pounds. Once again, the 24-volt version has a relay board for motor polarity reversal and both a multi-pin connector, 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connections for all inputs and outputs. And again, you will need to provide your own PLC and programming. There is a limited edition 9-volt version, which is currently available, which is pre-wired to a pre-programmed robotics TXT controller. And in that case, one 120-volt power adapter is required. The next model we're going to be looking at here is the multi-processing station with oven simulation. Now, the model we're going to see here features a furnace simulation with a pneumatic sliding door. There is a downstream processing station with a pneumatic transfer unit that includes a vacuum gripper, a cutter with a rotary table, and a conveyor belt. Components used on this model include 4 mini motors, 6 push-button limit switches, 2 photo transistors, 2 LED light barriers, 4 solenoid valves, and a compressor. The dimensions of the model are approximately 20 by 14 by 12 inches and has a weight of about 11 pounds. Again, the standard version of this model is the 24-volt version for use with the PLC of your choice, with, once again, a relay board for motor polarity reversal, and both the multi-pin connector, again, 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connections for all inputs and outputs. And there is currently a 9-volt version available, which in this case is connected to 2 robotics TXT controllers, and because of this, 2 of the 120-volt power adapters will be required. I do see a question coming up about what is needed in terms of pneumatics. Everything, whatever you need in terms of where pneumatics come up, whether it's this model or other models, that is included. So what you need to provide with these models, like I said, is with the 9-volt versions where you will need to purchase the additional power supplies, which I will mention that, and we would quote you on that. And in the case of the 24-volt versions, you have to provide the PLCs, the programming, unless otherwise mentioned, wiring, what have you. Moving right along, we're going to next look at the sorting line with color detection. I just got to mute this because it likes to talk over me. And the simulation you're going to see here features a system for detecting work pieces of different colors and sorts them via conveyor belt into 3 storage bins. Components on this model will include 2 mini motors, 5 phototransistors, 5 LED light barriers, 3 solenoid valves, a compressor, and an optical color sensor. The dimensions for this model are approximately 20 by 14 by 12 inches and has a weight of just about 10 pounds. Now, as with the models we've looked at before, the standard 24-volt version has the relay board for motor polarity reversal, again, multi-pin connector, 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connections for all inputs and outputs. And again, you need to provide the PLC and the programming. And the limited edition 9-volt version, again, will come pre-wired to the pre-programmed robotics TXT controller, and one 120-volt power adapter is required with that. We'll just let this play through the sorting over here. And there we go. So the next model we're going to be looking at is the factory simulation. And again, as I touched on before, this combines the 4 models we've just reviewed: the vacuum gripper robot, the automated high bay warehouse, the multi-processing station with the oven, and the sorting line with color detection, combines them all into one self-contained material cycle, as you see there. So we're going to look at a video of that. And the cycle that you're going to see works like this. Work pieces are retrieved from the high bay warehouse using the vacuum gripper robot, and then they get moved to the multi-processing station with the oven. And after the work piece has been processed by the multi-processing station, then it's sorted by color in the sorting line with color detection before being again moved by the vacuum gripper robot back to the automated high bay warehouse, again for storage. Now, as we've already discussed the components of each model previously, I'm not going to belabor it by restating it all here. But what I do want to mention is that the dimension of this model as a whole, because this combines the 4 individual models into one work cycle, it also has a much larger footprint. In this case, it's approximately 39 by 31 by 16 inches, and it has a weight of between 43 and 46 pounds, depending on whether you're purchasing the 9-volt or the 24-volt variation. Now, due to these dimensions, please note that this model will only be shipped flat, and that means we have to ship it as freight on a pallet. And I do have to mention that as the factory simulation models, whether it be these or the IoT-focused versions we're going to look at later in the presentation, these are all in very high demand, so please anticipate a 2 to 3 week turnaround time for any orders of this before they leave the warehouse. Currently, it is available in the standard 24-volt version and in very limited quantities in a 9-volt version. In the case of the 9-volt version, it's wired to 5 robotics TXT controllers, and as such, it will require 3 120-volt power adapters. So we'll let this play out for a minute or two here. And there we go. Now, before we move on to the next group of models, I do want to mention that there is a storage option available for those users of either of the two factory simulation models, which I just discussed, who want to transport the model or protect it when not in use. And also this storage and travel and storage case can also be used for the IoT focused versions we're going to look at the end of the presentation. The travel case itself consists of an aluminum case maker profile with plastic plates and steel ball corners, as well as 4 steel tilt handles and angle protection corners. The upper section of the case is partially lined with soft foam blocks in different heights to help cushion the models, and it has 3 internal zipper pockets for storing cables and other accessories. The lower portion is lined with hard foam and is designed so that once the top of the travel case is removed, the model can remain in the bottom section of the case, but yet still be fully functional. The case has exterior dimensions of approximately 41 by 33 by 17 inches. It has a weight of about 53 pounds, but do note that even when using the travel case, these models will still need to be shipped flat. So that being said, let's move on to some more models. Next model we're going to look at is a basic conveyor belt. And this is a transport belt with a length of 275 millimeters that is used to transport workpieces with a diameter of up to 29 millimeters. Multiple conveyors can easily be connected to increase the length of transport as desired. Components on this model include an excess motor, a push-button limit switch, 2 photo transistors, and 2 LED light barriers. Dimensions of this model are approximately 14 by 10 by 4 inches, and it has a weight of about 2 pounds. Now, as before, the standard 24-volt variation does include a multi-pin connector, but it's a little bit different than the other ones we talked about. In this case, we're talking about 26 pins with a 2.54 millimeter grid, as you see in this photo. And for a very limited time, we also offer a 9-volt version pre-wired to the robotics TXT controller as shown here. And in this case, one 120-volt power adapter is required for operation. The next model is a variation of the conveyor belt, which includes a punching machine. So this features essentially the same conveyor we just looked at, except of course this time it's got the machining station built in. Components on this model include 2 excess motors, 2 push-button limit switches, 2 photo transistors, and 2 LED light barriers. Dimensions of the model are approximately 15 by 12 by 7.5 inches, and it has a weight of about 3.5 pounds. Again, available in the standard 24-volt variation with the 26-pin connector, 2.54 millimeter grid as shown in this photo. And for a limited time, we do have the 9-volt version wired to the robotics TXT controller. And again, one 120-volt power adapter is required for that one. Next up is the index line with 2 machining stations. This model features a U-shaped conveyor line consisting of a milling and a drilling station and 4 conveyor belt sections. Components on this model include the 4 conveyor belts, as I just mentioned, 8 excess motors, 4 push-button limit switches, 5 photo transistors, and 5 LED light barriers. The dimensions are approximately 19 by 18 by 11 inches. It has a weight of about 8 pounds. Again, it's available in the standard 24-volt variation with the 26-pin connector, 2.54 millimeter grid as shown here. And in a limited release 9-volt version, pre-wired to the robotics TXT controller and requiring 2 120-volt power adapters. Next is a variation on the idea of a pick-and-place robot, the 3D or 3-axis robot. The 3-axis robot has gripping forceps, which it uses to help it quickly and precisely position the work pieces it picks up in 3-dimensional space. The degrees of freedom for this robot are as follows. Axis 1 turns 180 degrees. Axis 2 can move forward or backward 90 millimeters, and axis 3 can raise or lower 150 millimeters. Components on this model will include 2 excess motors, 2 encoder motors, and 4 push-button limit switches. Dimensions of the model are approximately 19 by 16 by 9 inches. It has a weight of about 6 pounds. Again, available in the 24-volt version with the 26-pin connector and 2.54 millimeter grid, designed for use with the PLC and programming of your choice, or available in a 9-volt version, which in this case is not a limited edition, is something that is going to be available, is available. It does come pre-wired to the robotics TXT controller and does require one 120-volt power adapter to power it up. Now, that concludes our line, the first 9 variations of simulation models. The next pair of simulation models focuses on the area of IoT, as I already touched upon, and is designed specifically for demonstrating and teaching about cloud-based monitoring and control. These models go by the name of Training Factory Industry 4.0, and they are available in both 24-volt versions for use with PLC, and also a 9-volt variation for classroom and demonstration purposes. Now, they've been designed to help address how the recent changes in industrial production, which of course were driven by digitization, have created a need for stronger networking and more relevant information on all production levels. With this Industry 4.0 update of the existing factory simulation model, such digitization activities can be simulated, learned, and applied on a small scale before, of course, you implement them on a larger scale. Now, as the following video showcasing the 24-volt version will provide a nicely narrated overview of just how the factory works, I'm going to step back for a moment and allow you to watch and listen to the narrator. So here you go. Oh, jumped a little bit there. Okay, so just to review a little bit, some of the topics that can be addressed with the fischertechnik Training Factory Industry 4.0, of course, are training and simulation on a realistic production model, in-depth learning through haptic comprehension, optical and sensory applications, digital traceability with NFC/RFID technology, customized production in lot size 1, integrated cloud connection and control via smart devices, using and operating dashboards, web-based remote maintenance, the linking of production materials and planning data, and the connection of upstream and downstream logistics processes. Now, as you just saw, the model incorporates many features not found in the models we previously discussed, besides most notably the use of the cloud-based dashboard for monitoring and controlling the model. Some other examples would be the camera that's used for visually monitoring the factory functions from the cloud-based dashboard, as well as the environmental sensor, which collects data on variables such as temperature, air quality, humidity, and air pressure. The use of NFC chips in each individual workpiece, each of which has a unique identification number, enables the positions of each workpiece in the work cycle to be mapped out. And the use of MQTT, message queuing telemetry transport, allows the network TXT controllers to communicate with each other. Now, as there are two variations of this model, let's go over what makes them different aside from the voltage requirements. We'll begin by focusing on the 24-volt version and what makes it unique. First, it is a bit of a hybrid in that while requiring a PLC for operation and control, it does also incorporate one fischertechnik Robotics TXT controller. Now, in this case, the TXT controller serves as the MQTT broker and interface to the fischertechnik cloud. Communication between the PLC and the TXT controller is carried out using an IoT gateway via OPC UA. OPC UA, which is also known as OPC Unified Architecture, is of course a standard for exchanging data across different platforms. Now, in addition to the TXT controller used here, there is also an IoT gateway using Raspberry Pi with Node-RED. This allows the option for not only presenting and using data on a dashboard in the fischertechnik cloud, but also to be able to display data and calibrate the stations of the factory in a Node-RED dashboard. The model also incorporates newly developed 24-volt adapter boards to interface to the PLC. These, of course, ship as part of the assembled training factory and are connected to the PLC via terminals. Now, among other things, the latest generation of adapter boards allows the speed of the encoder motors to be controlled via PWM, also known as pulse width modulation. And they also have push-pull output stages for phototransistors and for buttons. Finally, one of the most important new features, unlike any of the previous 24-volt models that we've discussed so far today, the new 24-volt Training Factory Industry 4.0 model also includes access to a sample program. In this case, the sample program is in structured text format and is created based upon a Siemens S7 1500 PLC. And this sample program is available for download on GitHub. Now, of course, the new training factory can also be controlled with other PLC models and brands once the end user makes some small adjustments to the sample program. And to enable you to be able to do that, the source code needed is also available for download from GitHub. Now, as with the first of the 24-volt models we looked at today, the Training Factory Industry 4.0 model has a relay board for motor polarity reversal and both the multi-pin connector. Again, these are 34 pins with a grid of 2.54 millimeters, along with PCB terminals with push-in connections for all inputs and outputs. Of course, all of this information and much more is included in the 152-page PDF manual, which can be downloaded from the fischertechnik website or which you can request from us. Now, moving on to the 9-volt version, the control is facilitated through the use of 6 robotics TXT controllers. Now, unlike all the other 9-volt versions we've looked at previously today, these are programmed not using the RoboPro software, but instead using C++. Again, all of the programming for this is preloaded as it is with all the 9-volt versions, so that once the connections to the internet and the cloud-based dashboard are made, all of which, again, are going to be clearly outlined in the downloadable documentation manual. Once you've done that, you should be able to get started pretty quickly. This 9-volt version, though, will require the addition of three 120-volt power adapters. Of course, it goes without saying that both models require the ability to access the internet as well as a tablet or a device for accessing the cloud-based dashboard. Getting to the dimensions for these models are approximately 39 by 31 by 16 inches, and they have a weight of approximately 51 to 53 pounds, depending on which one you're looking at. Now, as with the two factory simulation models we discussed previously, we do recommend the optional travel case to help protect your model during transport or even just during storage. And that's the Training Factory Industry 4.0 model, again, available in 24-volt and 9-volt versions. So, of course, you might well be wondering how much these models cost. So we're going to take a quick review of each option I've discussed along with the pricing. For the vacuum gripper robot, it's only available in the 24-volt version, and you're looking at a cost of $1,129.95 per unit. The automated high bay warehouse in the 24-volt version is $1,369.95. In the 9-volt version is $1,318.95. The multi-processing station with the oven in the 24-volt version is $1,199.95. In the 9-volt version, $1,474.95. The sorting line with color detection in the 24-volt variation is $1,049.95. And the 9-volt version is $1,128.95. The full factory simulation in the 24-volt version is $4,829.95. The 9-volt version is $5,239. The conveyor belt in the 24-volt variation is $324.95. The 9-volt version is $518.95. The punching machine with conveyor belt is $419.95 in the 24-volt variation, and in the 9-volt version is $599.95 per unit. The 3D 3-axis robot in the 24-volt variation is $999.95. The 9-volt variation is $1,369.95. And the index line with two machining stations in the 24-volt variation is $1,129.95 per unit. In the 9-volt version is $1,394.95 per unit. The Training Factory Industry 4.0 for learning, exploring, and understanding IoT-related processes in the 24-volt variation, this is $8,999.95. And in the 9-volt version, it is $9,024.95. Again, the 24-volt variation comes with access to the program and structured text. But we do have two additional variations to mention. There are two new versions of the Training Factory Industry 4.0 for 24 volts that are now available. There is one that includes the PLC connector. So this means that all of the additional wiring that one would normally have to do with any of these 24-volt variations, that would be the wiring that goes from the model itself to the PLC. Normally, that's something the end user has to do, but in this case of the model you see over here, 560841, there is one that includes the wiring and the PLC connection board. That variation is $12,079.95. And we do now have a version that includes all of that plus the PLC. So if you want to also receive the wiring, the connection board, and the Siemens PLC, again, this is the S7-1500. Again, it comes with the program. It is available for education at the cost of $18,499.95 per unit. And there is a commercial version as well. It's a little bit more. It's $20,124.95. The other two items we'll just touch on real quick here. As I mentioned it several times, you will need power adapters for some of the for all of the 9-volt variations and for a couple of the 24-volt variations. Those are $12.99 per unit. And the travel and storage case, which again is used for all factory simulation and Training Factory Industry 4.0 models, including the two variations with the connection board or the PLC. In any case, this case will work for that. It is $1,524.95 per. So on that note, if you have any questions, we did have a couple questions during the webinar. I answered those in the process of doing things, but if you do have any other questions, feel free to type in the chat window, use the question and answer window, both of which should be located on the Zoom toolbar. Feel free to put them up, going once, going twice. You can still put them up even as I see something. What were the dimensions for the factory simulation? Bear with me a second. I will pull that right back up for you. Again, we're looking at the factory sims, the training factories, pretty much all of those. You're looking at about 39 by 31 by 16 inches. And depending on the variations, if you're looking at the regular factory simulation, you're looking at a weight of between 51 to 53 pounds. If you are looking at one of the variations, the Training Factory Industry 4.0, you can go anywhere between 55 to 75 pounds. So that's how those differ. Again, any of those full-size factory models do need to ship flat on a pallet, so just know that. Okay, on that note, taking the next step. So whether you would like to request a full color brochure with the current pricing, if which I went over, but of course we have a sheet for that. If you'd like to ask any questions, if you would like to request a quote, speak to your dedicated educational representative or anything else, you can call us directly. The number in the US here is Studica is 888-561-7521. General questions can be directed to the email address info at Studica, Studica.com. Or if you have any questions specifically for me regarding anything that I discussed today, any aspect of fischertechnik, whether it be the training models or other products that they offer, that we offer, you can email me directly. And my email address, as you see on the screen, is lance.zurek. That is lance.zurek@Studica.com. So on that note, I would like to thank you all very much for taking the time to attend. Thank you for coming and have a great day. We look forward to hearing from you soon. Take care.